Hey everyone, welcome to another Polars tutorial. Today we'll be talking about another nested data structure in Polars, namely Polars lists. Now, if you've worked a lot with Python in the past, you may think you understand all there is to understand about Polars lists, and that's mostly true. But there's a couple key distinctions to keep in mind before you get started with lists. Namely, that's not the same as a Python list. You're not saving a Python list in a Polars data frame. It's a Polars implementation of the list. And so there's a key distinction you need to understand, namely that all the items nested within a Polars list need to be of the same data type. For example, you can't mix int and string or int and boolean, or everything has to be the same. So it has to be all ints, all strings, all booleans, all whatever it may be. So if you understand that, that's mainly the only beginner's trap that you're going to find with these. And so next thing you might be wondering is when you're going to encounter lists in your work, and you'll encounter lists two areas in a Polars program. One is when you create a list with your own code. So your code purposely creates a list. And then another, which is a little bit surprising and may take some people by surprise if they're just sort of exploring the code on itself, on your own. You can generate a list when you aggregate columns without specifying a summary statistic. And we'll go, and so in other words, if you do a .group_by and .ag and don't specify a summary statistic, it'll still collapse along those dimensions, but it'll aggregate all the items into a list instead of say taking the sum of them or something like that. So kind of a peculiar behavior, but also very useful too. And so we'll take a look at that in our example here. And so the code examples I'm going to show in this video is how to create a list with pl.concatlist. That's when you that's how you'll mainly create lists with your own code. Then we'll explore how to analyze data within the list. So we get data within the list. How do we start analyzing this and extracting some useful information from it? Once items are in the list, we'll talk about how to get items out of the list. So we'll talk about how to extract individual elements from the list. And then we'll create a list by aggregating a column. And then we'll show, okay, we have data within the list. How do we manipulate data in that list? In other words, once it's in there, is there anything we can do to change it without taking it out and running a Polars expression on each individual item? Is there a way to just globally apply a Polars expression across all the items in the list? And there is a way to do that. And we'll definitely explore all that. And so the first thing we're going to take a look at is just the sample data I made for this project. We're going to be using two sample data sets here. One's actually a real-world data set. This is just some sample test data, so 3 test scores, test 1, test 2, test 3. And what we're going to do is we're going to get these 3 test scores into a list. And so we'll go to the code to do that right now. So to create a list out of multiple columns, it's pretty easy. You just do within select or with columns, and you just do pl concat list. And then within the method, or the options of the method, you just write in the name of the 3 columns that you'd like to put in the list. And of course, we alias it because we're creating a new column. And that's really all there is to it. That's how you create a list out of pre-existing columns. And here's our new data frame, and we can see there's 3 items in the list which correspond to the 3 columns up above. And we see this new test scores column that we created here. We can see right here underneath in the data type section of the header, beneath the variable name, it does show us that this is indeed a list type column, and within the brackets it shows us the data type of the elements within the list. So I64 stands for int64, and so that means these are all integer values within the list that we created here. So this is an int type list. And so again, remember that if we have an int type list, we don't want to attempt to be putting strings in there as well. Okay, so we have these items within a list. Next, we'll talk about how to do some data exploration with these data. In other words, analyze these to get some useful information. So let's say we wanted to get, out of all these 3 test scores that we have in these lists, let's say we want to get the minimum, the maximum, and the average test score. And then we'll do a length as well to get the number of tests. So to do a method on a list that summarizes the data, we first have to point to the column, and so in each of these cases we only have one list column, so we're going to point to test scores. And then to use a list method, we need to first write .list, and that'll tell Polars that we're going to run a list method. And then just the name of the method that we want. And then we alias it to indicate that we're creating a new column. Now, this is just four examples that I'm showing. There are a whole bunch of summary methods or expressions that you can run on lists. I would definitely check out the documentation for all of them. I just didn't want to do anything overwhelming and just kind of give a brief introduction. But we'll go ahead and run these and take a look at the results. Okay, so we have 3 new columns, the lowest score, the highest score, and the average score. So notice that we didn't actually extract any individual elements out of the list. All we were doing here is computing summary statistics. So as we can see, it's actually quite easy to work with lists and to get information out of them and to analyze them. But what would happen if we actually didn't want the list anymore? Or maybe the data that we received on input contained lists, and we didn't want them in lists anymore. We wanted these in their own separate columns, and so we would need to extract each of these individual elements. It is pretty easy to do that as well. We'll take a look at that next. So the first thing we're going to do is we're going to sort the list, and this is another example. So of how you can manipulate the list itself. So to sort the list, you just do pl.call and then the list column, so test scores, and then .list and then .sort. And that'll sort in ascending status. If you wanted descending, you could put descending equals true in here. But the code I have below is assuming a ascending sequence. And so to extract individual elements from the list, we're going to start with columns. We, of course, point to the list column that we want. And then we do .list again. And to extract an individual element, we use the .get method. There's a couple other methods you can use. I find myself using .get the most. And since it's sorted in an ascending sequence, this first index column, oh yeah, and I think I forgot to mention, in the parenthesis, this is the actual item we want to extract. So 0 means the first item. The items in here are 0 indexed, so the first one is going to be 0. The last one is going to be the number of elements minus 1. So in this case, 3 minus 1. This one's going to be index number 2. So the first one we extract is going to be the lowest score. The second one is going to be the middle score, and then the final one is going to be the high score. And so that's why I gave it this naming convention. So we will go ahead and run that. Take a look at the results. Okay, so we see here that we have 3 columns now of extracted values from this list. So it's very easy to extract items from the list, very easy to work with the list in Polars. And so that's how you extract items from Polars. That's how you summarize it. And so next we'll go over another way in which you can create lists in Polars, and that's aggregating items across a dimension, or just aggregating a column without specifying a summary statistic. And we're going to use a different data set for this. I won't go over how I extracted and formatted this data. If you wanted to pause the video and just take a look at this, you absolutely can, but I won't go over it because it's not necessarily the point of this video. Basically, this is just some population data from 2020 from the US Census Bureau, and I have a region column, a state name, and a population. So what I'm going to do is I'm going to collapse along this region column, so I'm going to group by region. And then I'm going to create a list by region of these state names, so all the state names in each given region, and then the population items as well. So all the population items for a single region. And we'll put those into lists. And so to do that, to get a list by aggregating across columns, it's actually a pretty interesting thing Polars has set up here. So what you do So I'm creating a new data frame right here called state lists, and so you pass in the data frame you want. So this is called state pop, and then we .group by, and then .ag. And typically what we would do here with this ag is we would specify a summary statistic. So we would tell pullers the ultimate statistic we want to aggregate by. So do we want the mean? Do we want the median? Do we want the standard deviation, the average, something like that? But instead, if you don't specify an aggregation statistic, again, what it's going to do is it's just going to take all of those items along each dimension of region and just kind of smash it all into a list. And so we'll take a look at that. So pretty interesting, right? We see here underneath state name and pop that we have our aggregated lists. And we have a record for each region of the country. So West, Alaska, Arizona, so all the states in the West just in one list, all the states in the South in one list, and their corresponding populations. So that's how we create a list by aggregating a column. Next, we'll talk about how to actually manipulate the data in these lists. So let's say, we didn't want to extract these items one by one and manipulate them. We wanted to manipulate all these items at the same time before we go and create individual columns out of them or whatever it may be, right? Is there a way to do that? Is there a way to apply a Polar's expression globally across each of these items that we put in there? And there's a lot of items in there. There's like 20 or 30. There's 10, 20, 30 states in some of these lists. And there is a way to do that. And so what we're going to do is we're going to capitalize all of the state names here. And then we're going to express these populations in terms of millions instead of single digits. So we'll divide this by a million. So instead of being 12,799,000, it's going to be 12.7 million. It'll be 12.7. And again, to do that, we have to divide each of these items in each of these lists by 1 million. So, how do we do that? So to do that, we use two tools. Again, these are going to be list methods. So we're going to start out by pointing to the column we want and then .list. And then in each case, we're going to use .eval. And what .eval does is it tells Polars to run an expression against a list. And so that tells us that we're going to run an expression against the list. Next, we need to tell Polars to point to the items that we want to manipulate, and we do that with .element, and we use .element to reference all the items in a list. So how does that look programmatically? So again, we do .list and .eval, and then within the parenthesis we put .element, and again that'll point to all the elements within a list. And then here we do string to uppercase, and that's the Polar's expression to uppercase string variables. And then down here we do .trueDiv 1 million, and that'll divide each element in those lists by a million for the population column. So it is a very interesting, very nifty trick. One thing I always like about Polars, or any programming language really, is when they kind of set things up for you so that things just happen globally across a series rather than having to loop and to set up all these for loops and whatnot. I always appreciate that. And I think they did a pretty good job of that in Polars, or at least in this particular implementation. So we'll take a look at those data. Okay, so yep, down here we see all of our state names have been capitalized, and these guys have been divided by a million. So this is now 3.5 million instead of a single-digit state population. Okay, guys, so that's how you work with, that's a very, very brief introduction to working with lists and Polars. There's a lot more you can do with these lists. It's a very powerful tool, and I definitely encourage you to go check out the documentation and learn more. If there's anything else you wanted to learn about lists or anything else you wanted me to explore about them, feel free to write so in the comments. So thanks so much for watching, and have a good rest of your day.